Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about network file system, that is NFS, and its overview for the system implementation. What are the implementation, that is the statelessness of this NFS which we will use, and how to implement this NFS including this operating system, how to transfer remote files in the NFS, we will discuss today. Network file systems or NFS are in commonplace. They are widely used because they implement the overall directory structure and a client-server relationship. They are widely implemented as a client-server relationship maintaining all the directory structures and disk structures that is provided within an organization. Now this NFS protocol and the NFS networking virtual systems is used within an operating system to give us the virtual idea of having a larger space in the networking section of remotely handling of the files. Now the NFS is provided by some ONC Plus, which is supported by Unix and the other PC systems operating system that supports of it. Now, it is used mostly by the Solaris operating system, which supports the TCP/IP or either UDP/IP protocol depending on the interconnected networking type. Now, the NFS supports both the specification and implementation of a software system over and across LAN and sometimes WAN also. Now it views an interconnected workstation as a set of independent files as well as independent machines. So whenever we want to perform the remote procedure on these remote machines that are independent of each other, we can use the NFS as their file system mechanism. So now, after the file systems are mounted over these two remote systems, then we can perform the actual operations. So to begin with the NFS, we have the client to first access on the mounting done on remotely on the local file system. Say for a client want to access a remote file on a particular NFS system. So first it has to acquire the mounting operation done on that particular remote file system locally. After the remote file system is mounted over the top of the local file system, then the client has been performed and permitted to access the files under the directory of that particular mounted file system. Now the goal is to provide that some degree of sharing between the machines, that is a client-server relationship. Now to give the machine independence of this client server, any type of sharing that affects only the client machine, not the server machines that is producing the remote file system mounting. Now say if a machine that is providing a file system M1, so it will be produced by the client, the local file system to be toply mounted on the remote file. After the file system is mounted properly, then it looks like an integral subtree of the local file system of M1. Now the client can access every files that we have described inside that M1 operation. After performing the operations, then the client can again recall the close operation on that particular RPC to tell the NFS that it has finished its remote file system mounting, and after it can be demounted from the local file system to again get back the resulted robust remote file system which is being updated by the client. Now while we are giving an argument as the host name of the remote file system, it is not done transparently. As we have already told, after the host name is given by the client to the remotely file system mountation, then after the mounting is done in a totally transparent way, the client can access from files of M1. But other than that, the transparency is not maintained between the host and the server file names. So with an example, we will see that how the mounting is done. Here we can see three individual file systems where U is the local file systems of the client and S1 and S2 are two individual file systems that travels across the network via the NFS. Here the triangles are the directories that are needed to be intended to access of the files dir1 and dir2. So we need to mount these files from the NFS to the U and S1 to the U. So first we are mounting this S1 to the U. So when we are mounting the S1 to the U, the local subdirectories that are present here will not be anymore visible to the local users. Now after the shared dir1 is being shared to this U, then the access location of U user local dir1 will be our new directory that is mounted on remotely. So now we are mounting the S1 user shared to the U user local. So now after the mounting is done, the result is this system structure. So now the user can integrally and transparently access any files under this dir1 from this user local directory. And as we can see that the local directory is not anymore visible to the users of that particular file system machine. Now as the dir1 become the integral part of this local now, so the shared is topped upon this local and it is mounted on that point. So this part of this remote file system that the client can access. So after the user local and dir1 can be accessed by a client, then it can be unmounted and it can be again give back to this S1 and U1 to the previous systems. Now subject to the access rights credentials, we can say that any files can be mounted over any of the top of any local system. So the shared can be top of this local or otherwise the shared can be mounted on top of this user too. So it does not depend on the local file systems that which positions the remote file system will be mounted. A diskless file system can get their own root from the server by the root of the server as then the diskless mountation. Now whenever this type of performance is done, we can use the cascading mounting. The cascading mounting supports that if a local system is already mounted on a remote file system and another file system is now want to mount after the remote file systems, then it will be mounted inherently or implicitly. So any mountation like this can be accessed by only the files that is mounted by this S1 and U1. Say for an example, S2 now wants this dir2 to be mounted on this user local. So as S1 is already mounted user local dir1, so we can say that the dir2 mounting will not be visible to the user of that particular client because it can access only the dir1 of the S1. But the client from S2 can access from the dir1, that is this user local dir1. This path will give access to all the files that presents inside this directory. So again mounting or cascadingly done by this exact resulting same mounting of the remote file system. So in this way, cascading mounting helps in remote file system mounting on the top of another remote file system mounting. However, the client can only access the local file systems that has become the integral part of that remote file system mounting. Now, if a shared file system is mounted over any the user local or the home directory of any operating system, then it can be integrated as any part of the home environment of that particular operating system, and the users of that particular system can use all the files of this dir1, dir2 as well as the local because the systems are mounted on the home environment. Now, NFS takes an advantage of the heterogeneous nature features, that is using the both different operating system, different file system, different networking architecture. When we are using this heterogeneous architecture, we have to support by the NFS different types of file system types to be mounted over the same file location. Say this dir1 having a type of system files and dir2 having another type of system files. So these two can be mounted to the local, as because local is a part of an NFS which will support both the files of dir1 and the files of dir2. So the heterogeneous nature of NFS can support to be an advantageous on multi-types of file systems. And this independence can be built only in front of the RPC, that the remote procedure calls, and built top of the XDR, that is external data reduction. Whenever this XDR is used on top of this RPC, then only the independent of this implementation algorithm provides this NFS, thus heterogeneous features working. So in this way, NFS provides two types of performance. One is the mounting mechanism and another is the remote file access. So to perform these two actions, it needs two types of protocol, the mount protocol and the NFS protocol. The NFS protocol deals with the remote file accessing operations. So the complete performance of the NFS depends on the successful operation of these two protocols and applying them to both the operating system of the client side and the server side. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.